In this video, I'm going to show you how to observe your CrewAI crews using OpenTelemetry. Let's get to it. So I'm doing nothing really special here. I'm following the CrewAI getting started quick start guide. I'm using OpenAI. Again, nothing special. I've done CrewAI create crew my first crew, which gives me all of the scaffolding and all of the files that you'll get. Then I've downloaded my backend. Now for me, I use OpenObserve. It's a single binary. The link will be in the video description if you want to download and extract that binary. When you start it up, you need a username and password. So let's first of all start the observability backend. And that runs on port 5080, and as you can see, no data ingested yet. I've just started it for the first time. How to ingest data? Let's go there. Now, of course, if you're using a different backend system, this will be different, but that's okay. That isn't the point of this video, which backend you're choosing. This will work with any of them. So anyway, in OpenObserve, go to Custom, go to OTel Collector, and then copy and paste this key, and we're going to use it down here when we start the collector to set an environment variable called OpenObserve key, and I'll show you why in a moment. But for now, let's start up the OpenTelemetry collector, because the CrewAI process is going to send the telemetry data to the collector, and then the collector is going to forward it on to our whichever backend you're using. So let's start up the collector now, and then I'll show you the YAML file. And there we go, it's running. So let's have a look at the collector YAML file. We are going to receive our data from CrewAI via OTLP on the standard port of 4318, and then we are going to send it. If we look down here, we're going to send metrics, traces, and logs, all three signal types. We're going to receive them all on OTLP, and we're going to send them to both debug, which is the console output that you're seeing down here, and we're going to send it to our backend system. This is where it'll differ if you're using a different backend system. Ask your vendor for how you get data from the OpenTelemetry collector to them. It'll be something in the exporters block that looks like this. Okay, so we've got the two pieces running now. We've got the backend and we've got the collector. And now all we need to do is tweak the CrewAI settings just slightly to make this all work, and then we'll start things up and see what we get. So in my first crew, open up the pyproject.toml and add a new dependency you see on line 9 here called Traceloop-SDK. It's the Traceloop SDK that's going to actually trace the CrewAI and give us that telemetry output. So just add this line. In my first crew, you can see a folder called src source. Go in there, my first crew. Look at main.py, and we need to add 2 lines at the top here. From traceloop.sdk, import traceloop. That's the first line. And then traceloop on line 9, traceloop.init API underscore endpoint is pointing to our collector. Remember, our collector is running on localhost, listening on port 4318 for that incoming data. So here we are pointing CrewAI to the collector, and the collector, as you've seen, already knows about our backend system. So API endpoint is localhost 4318, and just for niceness, I suppose, we're giving it an app name, which I've just decided to call CrewAI. You can call yours whatever you like. So those 2 lines in main.py, and don't forget the Traceloop SDK in pyproject.toml. Follow the CrewAI instructions to activate the virtual environment, and then basically run your crew. So open another terminal. You should have 3 by now if you're following these instructions. You should have OpenObserve in one terminal. That's your backend. You may or may not have that. You should have the collector in another terminal, and we will open another window and do CrewAI run. And you'll see it starts up. It starts thinking. It starts doing whatever it does. If you want to watch the output of this, go into the OTel call contrib, the collector window, and you should start to see output being spat out into the collector. So that is telling me that the data, the telemetry data from CrewAI is getting to that middle point, getting to the collector, and then hopefully it's getting to our back-end system. But we'll let CrewAI run, and then we'll have a look at what it looks like in our backend. Perfect, there we go, we've got some output. The Getting Started guide asks for, a comprehensive report on the state of AI agents in 2025, and there we go, there's our output. CrewAI worked, we know the telemetry got to the collector. Let's have a look in OpenObserve. If we go back to home, we can see some data streams there, that's good, that suggests data is in the backend. We don't have any logs. We have some metrics, that's good, and we have some traces. Now, the gold standard is tracing. Tracing gives you that end-to-end, piece-by-piece picture. So let's first start with traces. So, wonderful, we've got a trace, CrewAI, that's the name of the application name that I give it, CrewAI Telemetry. It's called CrewAI Workflow. It took 35.25 seconds in total, and there were 12 individual things that happened in this end-to-end sort of workflow, and CrewAI has helpfully bundled all of that together into a single trace. And that's the power of traces, is the ability to group everything that happens together. So let's have a look at what we get. The UI looks a little bit odd, actually. I'll flash something on the screen now. I would expect it to look more like this, like a Gantt chart. So time running left to right, longer bars being longer things that happened. It's a bit odd that I think this is just this backend, and maybe it's a little bit broken at the moment, but your backend obviously should visualize this correctly. The main thing is here. So we've got these 12 individual steps. We've got the crew being created. That took 500 microseconds. We've got conduct a thorough research about AI agents. We've got all of this metadata here that we can further process and alert off. So you get with these traces and spans, you get very deep level analytics of everything that went on. You can see this step took 7.87 seconds. Let me close that. Then the task was created, and our senior data research agent got involved. So we started doing the research, and to do that, we can see we had to go out to GPT 4.1, Nano in my case. We hit OpenAI, and that took 27 seconds. And then we reviewed, and then the reporting analyst got involved, and that took 27 seconds as well. And so you can see, basically, the point is you can see everything that happened. You can see when the agents did their thing. And so if you've got multiple agents, it's really essential to see what they're doing and when they're doing it. Because if you had 10 agents here and things were taking 5 minutes to achieve, you really need to see who's handing off to who, what data are they passing backwards and forwards. And as you can see, you get a huge amount of information, all of the prompts and the backstory and what comes back from the model. I'm not going to show you that because it's actually got my API token in, which I don't think it should, but that's just me. As I say, you've got a wealth of information here. And that's it. We just we instrumented the CrewAI Python file with Traceloop OpenLLMetry, and we passed it to the collector. We didn't really do anything in the collector, but if you've seen my other videos, you can do a lot of data processing, stripping of data, dropping of data. So that API token that I'm complaining about, I could, if I wanted to, strip that out of the collector and just kind of star it out, taking this a step further. And I would recommend that. I'd run this in non-prod. I'd look at the output and I would say, I'm not sure I want that in the output. But there you are. If you found this useful, like, subscribe, all that good stuff. And that's how easy it is to observe your CrewAI workloads with OpenTelemetry. I'll see you again very soon.